Right, grade 12s, on to more applications of the knowledge that we have of trigonometry thus far. This exercise requires very little more knowledge than what you already have from grade 11, because you were asked these exact questions in grade 11 and you did really well in them. So I hope you're excited to just extend a little bit on to questions that require sketches. Now, there were two kinds. I even remember drawing a flow diagram on the board last year that stipulated when you are required to draw a sketch. Most times the question will be kind enough to say with the aid of a diagram, but still you are going to need to know what kind of diagram are you going to need to sketch. Trigonometry, always relates to triangles, and to be more specific, right angle triangles, because that is the triangle that we need in order to apply SOHCAHTOA. So the first instance in which you'll need to sketch a right angle triangle is when you are given a trig ratio and its actual value as a fraction. As well, and you'll also be given an interval. So these are the questions. This scenario number 1 is what I like to call the if and interval questions. They'll say if sine theta equals -5/13 and theta lies in a specific interval. So if you see an if and an interval kind of question, then you must realize you need the cast diagram along with those two pieces of information to be able to draw a right-angled triangle in the correct quadrant. Once you have this triangle in the correct quadrant, you use Pythagoras to solve all three sides of the triangle, and then you'll be able to interpret and solve for any question that they throw at you. The second situation in which you'll need to sketch is when you are given an acute angle. So now you're not given a fraction, now you're given an actual degree. And that degree is always, well, 9 times out of 10, an acute angle. If it's bigger than 90 degrees, we can usually reduce it to an acute angle and then apply the same strategy that I'm about to show you now. So if you are given an acute angle, for example, cos 36, and you are told that it's equal to a variable k, they love k, usually k or t, P, S, or R, or M, when we have, and then the instruction will be to write other trig ratios in terms of that specific variable. So that is when we also need to sketch a right angle triangle. But because we know we are dealing with a specific acute angle, we know that we're working in quadrant 1. So all you actually have to do is sketch a right angled triangle, fill in the degree, and then also use Pythagoras to solve the third side of the triangle, but that third side will be written in terms of the variable, in terms of k. Another piece of advice that I can give you with these questions, when it comes to these questions, is to always solve the third angle of the triangle as well. So that third angle, it will usually be at the top of the triangle, will be 90 degrees, well, will be 180 degrees minus 90 degrees minus the degree you've been given, in this example 36. But I will elaborate on that in an example a little later on. For now, I know you love notes. Jot down the two scenarios in which you'll need to sketch right-angled triangles. Okie doke, so we're jumping straight into an example. The example is taken from page 146, exercise 4.6, which is your homework today. But I insist that you please read example 8 on page 142, because it deals with the exact same concept. It just uses different numbers. So by going over this example as well as the example on page 142, you'll have a clear understanding of what's expected from you in the exercise. Rightio. So once again, I said if and interval kind of question. That means we're going to need our cast diagram to help us decide in which quadrant we need to sketch a right angle triangle. Let's look at the first piece of information we've been given. sine theta is negative 5 over 13. Now in the previous slide, I said take note of that sign. In other words, sine theta is negative 5 over 13. So we need to go and put a little star or a dot or a tick or whatever you like in the negative sign quadrants. So that is quadrant 3 and quadrant 4. Now we move on to the next piece of information, and that is the interval that was given to us. If theta is bigger than 90 degrees but smaller than 270 degrees, that means we can put a little star in quadrant 2 and 3. Now where the two pieces of information coincide, so quadrant 3, that is the quadrant in which we need to make our sketch. So the if and interval part of the question is all done and dusted. We've used those two pieces of information, the orange and the green, to establish where we are going to make our sketch. So let's go ahead and sketch it. Y-axis, x-axis. Look at how I've made a lot of space for quadrant 3. You don't really have to worry about the other quadrants, so your Cartesian plane doesn't have to be 4 perfect grids. Then we sketch a right angle triangle. Note the right angle symbol in the correct quadrant, and also note that the right angle is on the x-axis. If you remember the bow tie method, if you were to make a bow tie diagram on top of your cast diagram, this would be the bottom left corner of the bow tie. Please don't be making right angle triangles where the right angle is against the y-axis. That won't work. Right, then we apply our angle. The angle always starts on the x-axis and always ends on the hypotenuse. Now I know our SOHCAHTOA rules will refer to that acute angle there between the negative half of the x-axis and the hypotenuse. But the only reason we're working in that triangle is because of the beauty of reduction formulae. It allows us to use the acute angle in that triangle. But what we need to remember is that theta is actually the angle from the x-axis all the way to the hypotenuse. So theta is essentially an obtuse angle. It's not acute, even though we are going to work within that little acute angled triangle. Now, remember that SOHCAHTOA tells us that sine is opposite over hypotenuse. Let's go and fill that relevant information in on the triangle. The negative, even though it was in front of the fraction, we must realize that that negative belongs to the 5 because quadrant 3 has the negative half of the y-axis, and a hypotenuse is always positive because it's a distance. We cannot read the value of the hypotenuse off one of the x or y axes. How do we solve for the third side of this triangle? Pythagoras, of course. If you see a 5 and a 13, I hope you realize that x must be 12 because of your Pythag triples. If you don't know your Pythagorean triples, that's okay. Just use the theorem of Pythagoras and then use Pythag as a reason after you've calculated that x equals 12. Another alarm bell is that because we're in quadrant 3, you have to label that x as negative 12. You will lose a mark on your sketch if you don't put it as a negative on your diagram, because we are working in quadrant 3, which has the negative half of the x-axis. Rightio, now we have all 3 sides of this triangle. We can tackle question 1, 2, and 3. 1. Cos theta. SOHCAHTOA, cos is adjacent over hypotenuse. Adjacent was negative 12 and hypotenuse was 13. As easy as that. Question 2. Sine 2 theta. Now this is the only instance where it becomes a little bit more complicated than grade 11. Now you just have to apply the double angle identity for sine. And you see that we actually have sine 2 theta can be equated to 2 sine theta cos theta. And then we can substitute in the relevant values for sine theta and cos theta, which will equate to, I repeated myself, which will equate to 120 over 169. Perfecto. Then question 3. We have the double angle identity for cos. So we apply any one of the 3 double angle identities we have for cos. The reason I have chosen to apply 1 minus 2 sine squared theta is because sine theta was given in the question. What if for some reason I made an error on my sketch and I calculated incorrectly? Then that would infiltrate into my sub-questions. So if I am using the information given to me in the question, then I am minimizing my risk of substituting incorrect values into my formulae. So this is why I've chosen the 1 minus 2 sine squared theta. Substitute the opposite over hypotenuse value in the place of sine. Don't forget to square it, and we end up with a negative 119 over 169. Ready for the next one? Right, the second example will allow us to apply the second scenario where you will be required to draw a sketch. These kind of questions are called Pythagoras questions. Even though we used Pythagoras in the first scenario, I like to call the first scenario if and interval kind of questions and the second scenario Pythagoras questions, because you see the format of Pythagoras pretty much in your final answers usually. So if you are given an acute angle, you already know that that angle is in the first quadrant. So for cos 36, we know 36 degrees falls within quadrant 1. So all we actually need to do is sketch it and realize we're dealing with positive y, positive x, and obviously positive hypotenuse values. So the next bit of interpretation you need to do is, after making a sketch, a 90-degree triangle with 36 as the acute angle, it's a good habit. I've noticed that it doesn't really give us an advantage for this question, but it's a good habit to always work out the third angle of that triangle, and to be pedantic about our reasoning, just pop in a reason of sum of angles of a triangle near to that number when you work out a third angle of your triangle, because you will be required to make this sketch. Now that we have the variable k, we need to convert that into fraction format so that we can apply SOHCAHTOA. We know that cos is adjacent over hypotenuse, so k over 1 can be linked up with relevant values in this triangle. K will be your adjacent to 36 degrees angle, and your hypotenuse can be the number 1. We have 2 sides of the triangle, so we've got to use Pythagoras to solve the third side. Because the third side of this triangle is a vertical line, I use the variable y to represent a vertical distance. Y squared equals 1 squared minus k squared. Pythagoras. We have the hypotenuse, hence we're doing a subtraction sum for Pythag. Then we square root both sides to get y all by itself. Obviously 1 squared is just 1, so I left it as that. And k squared I'm keeping as k squared. Do not make the cardinal sin or the fatal error of splitting that square root and simplifying it to say 1 minus k. You cannot split a square root sign over plus and minuses. That will lead you into dire straits. Do not do it. That is your final value for y. So we go and pop it into the sketch there along the vertical line. Don't forget to write your reason as Pythag. You'll lose a mark. These questions are for very little marks, considering how much thought process and how many details you actually include on your sketch. It's quite sad, but on the other hand, it's straightforward and it's easy marks if you remember what kind of sketch you need to draw. Now, with 3 sides of the triangle filled in, we are ready to answer the questions already, just like that. Number 1, cos of negative 36. You can, using our reduction formulae, we can convert negative 36. It's in quadrant 4. So cos of negative 36, we must realize is actually just the same as saying cos of 36, which was given to us in the question as k. Chuff chuff, that's just done, easy peasy. Number 2, cos 72 degrees. Your brain needs to make the link between 36 and 72 and go, aha, aha, double angle identities. I'm choosing one of the 3 options for cos's double angle identities, and the one I'm choosing is the one that links up with cos 36. Why? So that I don't need to do too much thinking and I can just substitute in the values given to me in the question, hence minimizing my risk of making an error. So instead of cos 36, cos squared 36 will just be k squared. So the final answer is 2k squared minus 1. Number 3, sine of 36 will lead us back to our diagram where we need to consider SOHCAHTOA. Start at the 36 degrees, see that 1 minus k squared, all square rooted, is the opposite value, and over the hypotenuse value is a 1. That is perfectly fine as your final answer, but obviously we can easily drop that 1 because anything divided by 1 will stay itself. So that's what I'm going to do in the next question. Sine of 72, once again, double angle identity. There is only one option for sine, so sine of 2 theta becomes 2 cos theta sine theta, or sine theta cos theta, the order doesn't matter, and we just substitute in the relevant values there. Cos 36 degrees was k, and sine 36 degrees was the square root of 1 minus k squared. Please let me know if you have any queries. Otherwise, please go on to complete the rest of exercise 4.6 after looking at examples 8, 9, and 10 before exercise 4.6. Thank you and good luck.